Bismillahir-Rahmanir-Rahim. My topic is Heavenly Monuments of Sawai Jai Singh II, the last flowering of traditional Islamic astronomy. The Quran says, "In time we shall show them our signs in the utmost horizons of the universe, and within their inner selves, until it will be manifest unto them that it is the truth. Doth not thy Lord suffice, since he is witness over all things?" UNESCO inscribed the early 18th century Jantar Mantar Observatory in Jaipur, India, on the World Heritage List of cultural sites of outstanding significance to mankind. It is somewhat difficult for us today to comprehend what a central place astronomical research and related mathematics occupied in the everyday life of the pre-modern Islamic world. In Islam, it is mandated that prayers be performed at the correct times and facing the Kaaba in Mecca, and that a range of religious functions be carried out according to an accurate lunar calendar. Study of the movements and relative positions of the sun, the moon, and the stars in relation to the earth was essential in providing the basis for the exact computation of time, the calendar, and geographical location in the proper implementation of God's will. From the early days of Islam, Muslim scholars were engaged in astronomical investigation. Although they drew on texts from various cultures, it was the astronomical science of the Greco-Hellenistic world which became the principal foundation for the developing discipline of Islamic astronomy. At its core was the world of the Alexandrian Ptolemy, 100 to 170 CE, who propounded the geocentric notion that the sun and the planets revolved in circular orbits around a spherical and motionless Earth. Because the solar system is heliocentric and the orbits of heavenly bodies are not perfectly circular, observations interpreted on the basis of the Ptolemaic model yielded data logically inconsistent with the theory of geocentricity. In the endeavor to solve these quandaries, complex astronomical measuring instruments were devised. The majority used in Islamic astronomy, such as the astrolabe and the quadrant, were handheld and of metal. Like sundials, which measured time by plotting the positions of the sun's shadow, they had long been in common use but were further refined by Muslim scientists. A primary practical outcome of astronomical observation were tables of the positions of sun, moon, planets and stars called Zij, which were used as the basis for a great range of calculations and activities in the pre-modern Islamic world. Although there were many small or medium-sized observatories throughout the Islamic world, installations with much larger instruments designed to yield data which it was impossible to gather with smaller devices were also occasionally constructed. Notable was that established in about 1259 by the Mongol ruler Hulagu Khan, 1218 to 1265, in Maraga in Iran. It was staffed by leading Muslim astronomers, and its crowning achievement was the Zij-i-Ilkhani by Nasir al-Din al-Tusi, published in 1271. This was widely used until a new Zij was created in 1438 by Ulugh Beg, 1394 to 1449, on the basis of data gathered in the next major astronomical observatory of the Islamic world, which he built in Samarkand in 1424. The Zij of Ulugh Beg was widely used as an authoritative reference, including by successive emperors of the Muslim Mughal dynasty, who from 1526 controlled most of northern India. It was the custom of each new ruler to have a new Zij formulated which reflected his calendrical epoch, but which was derived from the famous Zij of the past. This practice continued until 1720, when Muhammad Shah, 1702 to 1748, ascended the Mughal throne. One of his principal allies in the multi-ethnic Mughal court, Maharaja Sawai Jai Singh II, 1688 to 1743, the Hindu ruler of Amer, was passionately interested in astronomy. He asked and was given permission by Muhammad Shah to update and correct the previous imperial Zij through observations to be gathered in a new type of observatory which he would build. Sawai Jai Singh was convinced that the primary causes of the perennial problem of inconsistent and inaccurate raw astronomical data were that most observational instruments were small and of metal, generally brass. In the Zij-i Jadid Muhammad Shahi, the new tables of Muhammad Shah, which was the formal outcome of his work, the underlying explanation is given thus. The brass instruments did not measure up to the ideas that he, Sawai Jai Singh, had formed about accuracy because of the smallness of their size, the want of their division into minutes, the shaking and wearing of their axles, the displacement of the centers of the circles, and the shifting of the planes of the instruments. Sawai Jai Singh decided to resort to size to address these dilemmas. From 1721 onwards, he built 5 observatories, each with arrays of massive masonry observational instruments, first at Shah Jahanabad, where Muslim astronomers played the major developmental role, and then at Jaipur, Mathura, Varanasi, and Ujjain. Building in masonry on a large scale was intended to solve the 2 basic problems associated with A, the material instability of metal instruments, and B, their small size, which limited subdivisions of measurement on the body of the instruments themselves. During the time Sawai Jai Singh was evolving his new instrument designs at Shah Jahanabad, he was also embarking on the constructing of a new capital for his own realm, Jaipur, the first planned city in India. As an integral part of his new palace complex, he built the Jantar Mantar calculating instrument. This is the greatest of his observatories, with 19 principal instruments or groups of instruments, including the 22-meter-tall Vrihat Samrat Yantra, the great king of instruments, probably the largest Norman sundial ever built. Scholars of various cultural and scientific traditions were involved: Hindu, Muslim, Jain, and European. Astronomical and related scientific texts in Arabic, Persian, Greek, English, French, German, Sanskrit, Hindu, and Latin were acquired from near and far and translated, and new texts were written. Sawai Jai Singh was particularly keen to draw on contemporary European scientific knowledge. However, although his obvious choice of scholarly European collaborators, locally available Portuguese Jesuits, was logical, it was, unbeknown to him, flawed. The Portuguese were the first Europeans to establish a permanent presence on the Indian subcontinent. It was the policy of the Roman Catholic Church to use the Jesuits to promote its influence there. Their beliefs were to radically affect the orientation of the work of Sawai Jai Singh. The late 16th and 17th centuries were a period of revolution in European astronomy. Copernicus, Kepler, Bruno, and Galileo were proving that mankind lived on an Earth that was a planet of the Sun and not vice versa. This completely overturned Roman Catholic theology and enraged the church hierarchy, of which the Society of Jesus, the Jesuits, was a critical propaganda tool. For the Jesuits, the church had absolute authority. It was, by papal decree, literally forbidden for the Portuguese astronomers with whom Sawai Jai Singh was in contact to divulge anything about the brand new European scientific revelations. For his Portuguese collaborators, as for Sawai Jai Singh and his local Hindu and Muslim experts, Ptolemaic astronomical understanding still ruled their work. The data so conscientiously gathered in Sawai Jai Singh's name were to be as accurate as they could be for the time. Some instruments were conceived in ways which are still valid. His great Jaipur sundial, for example, was capable of recording time accurately to within 2 seconds. Others, however, were based on astronomical concepts which the Copernican revolution revealed. as invalid. Thus, misinterpretations and miscalculations continued to proliferate. The Zij-e-Jadid Muhammad Shahi was completed in 1731-1732 and was used in conservative Indian communities well into the 19th century. The last known Islamic Zij, the Zij-e Bahadur Khan, was published in 1855 by the Indian astronomer Ghulam Hussain Jaunpuri, 1760 to 1862. He incorporated heliocentric theory into the traditional Islamic Zij table format. Maharaja Sawai Jai Singh II died in 1743. His observatories, based as they were primarily on Islamic interpretations of Ptolemaic notions, were constructed on the cusp of the ascendancy of the new Copernican understanding of our immediate cosmos. These magnificent structures and the body of scientific work the Maharaja generated are indeed monuments to the heavens and represent the last and arguably the greatest flowering of traditional Islamic astronomy, which ended, as it had started so many centuries earlier, in an atmosphere of openness to knowledge from other cultures and other perspectives.